Okay, today we're going to be looking at section 8.2, systems of linear equations with matrices. Now there's a vast amount of information to be learned here. I'm only going to give you a bird's eye view sketch summary of this information. I will model it as well as I can in my math lab. And then hopefully you will be able to replicate the process. So first we see two equations. Here we have x plus 4y equals 14, and then we have 3x minus 2y equals 0. The augmented matrix only deals with the coefficients of the variables. So, in front of this x is understood to be a 1, and that's why there is a 1 here. In front of the 4y, or in front of the y is a 4, and that's why we have 4. And then on the other side of the equal sign, represented by this vertical bar, is 14. And then the bottom equation, we have 3 minus 2, so they represent that with a negative 2, and then 0. So as we go on, this is just a definition of what a matrix is, identified by rows going across and columns aligned vertically. They are given indexes or indices labeled by I and J, and you can refer to any row or any column given the proper notation. So I is the row index, J is the column index. So this example A23 refers to row 2, column 3. So if we came down here, row 2 and then be column 3, that would be A23. That would be that position. So here's the definition of augmented matrix. One thing you do need to be careful of is over here in yellow words. It talks about what it is. You also need to be aware of this caution. Make sure your variables are lined up. So make sure x's are aligned vertically, your y's are aligned vertically, and then your equal signs are aligned vertically so that your number aligns on the right side. That needs to be true before you can set up your matrix. Otherwise, it will not work correctly. So those are like the first things you need to do. If you're going to take a system of equations and convert it to a matrix, you have to make sure everything is vertically aligned. So if you look at this one, it has x, y, and z. And then the next equation has x, no y, but then it has z, and then minus 1, and then equals 0. So this is not lined up at all. They would need to move this 1 over, and they would need to put a 0 as a placeholder in the position of the y. So as we look further down the page, we can kind of see that that happens. Here's that 0 as a placeholder for the y. They move the 1 over so that everything is aligned. So you have to make sure everything lines up. And then once you do, you can convert it to matrix, and then we will begin to solve them. So there are a lot of operations. So here are some of them. We can interchange rows, just move them one to the other. We can replace them, we can add them, we can multiply them. I'm going to show you all that in my math lab. Here is an example of what a row operation looks like. What's happening here is we're going to replace row 2, and this is what we're going to do. So this R2, big capital R with a subscript of a 2, means we're going to replace row 2, and the new row 2 is going to be equal to this operation. So that means negative 4 times row 1. So here is row 1. They're going to multiply this by negative 4. All right, so that would be 1 times negative 4. That's this term right here. And then they would also do 2 times negative 4. So that is this term right here. And you also have to do that to the number on the other side of the equal sign. So that would be 3 times negative 4, which is this term here. We're going to add that to the original row 2 terms. So negative 4 times this plus 4. So you see that that's why they have the plus 4. Negative 4 times this term above, and then plus the negative 1, and then negative 4 here. So when they do all of that math and they simplify it, they end up with this new matrix. And the reason why we do these row operations is to simplify it in what we want, or what we call row echelon form or reduced row echelon form. So you have several examples here that you can look at. It may be kind of hard to follow, but they're showing you step by step, trying to get you to see this is what's happening, and then they show you the result. You're going to be doing those to get row echelon form. That's important. You're going to be asked to identify matrices that are in row echelon form, and here is how you know. The entry in row 1, column 1 is 1, and only zeros appear below it. So like this. The first row, first column is a 1, below it is a 0. And for every other row you would have below it would be a 0. And then it says the first non-zero entry in each row after that is a 1, and only zeros appear below it. And then you have a few other things, but those are the main things to look at. Let me just kind of give you an overview. This here, we have the first row, first column, a 1, zeros below it. And then the next row, the first non-zero entry is a 1, and only zeros below it. So it's like 1 all the way down the diagonal, and then only zeros in front of it. That's the general idea. You could have a row with all zeros. Sometimes that means you have more than one equation that are equal, which we'll get to seeing that here shortly, and talking about how to read a matrix. But they're just showing you more operations here. I want to show you this by hand and with the calculator when we get over to my math lab. So here is just another result showing you moving and how to get the ones all the way down the diagonal so that we get this in row echelon form. Now we're going to get to the point to where we're solving. So this is all that we're going to be doing. We're going to write it, the equations in the matrix form. We're going to use those operations to get a 1 in the first row and column. We're going to use that row to manipulate the other rows to get 1s all the way down the diagonal. And we'll just continue to go through this point until we reach row echelon form. So here is solving the matrices. So to give you an example, here's a matrix, or here's a system of equations. Here it is in matrix form. They also call that coefficient form, I believe. They start to solve it. As we get to the end, when we have 1s down the diagonal, here this is what we call row echelon form. And what happens is these numbers represent the variables that that we removed. So 1 here is 1x, minus 1 is minus 1y, 1 here is 1z. And as you look at this, this will help you to identify values for x, y, and z when we try to solve it. So here we can see that z is 1. So if we replace a z with 1 here, we will be able to solve the y equation. So plug a 1 here, and then we would add 12, and that's how we get the value for y equal negative 3. And now that we have z and y, we will plug both of those in up here. 1 and negative 3 will become a 4. And if you were to subtract 4, you would get that x equals 4. And so that's how you get the ordered pairs here. But we will show you that in writing. You can continue the process of row echelon form to obtain, did I skip it? Reduced row echelon form right here. Reduced row echelon form says you're going to get 1 all the way down the diagonals, only zeros below the ones and zeros above. So we'll also cancel out those. That's what this is explaining. And so they continue this process, and they're showing you with the row operations how they are manipulating and getting the other terms to be 0. And then once we do that, we will have all of our answers that we just saw. This first position was x in that column, so 1x is 4, so x equals 4. Y's were in the middle column, so right here where we have a 1, that is telling us y is -3. And the last column was z, so right here where we have a 1, that's telling us z is 1. You just have to remember the position of your x, y, and z, and that's why it's important to have them lined up. So here's one where we're solving a dependent system, meaning that one of these equations is the same. How you will identify that is when you begin to do the row echelon form or reduced row echelon form. If you notice that one row completely zeroes out, okay, 0, 0, 0 equals 0, that is a true statement, then that means we have a dependent system. So one of those equations is the same. And usually if that's the case, we would represent the solutions in terms of one of the variables, like z equals and x equals or y equals. But if you notice that, then also, if that could be the case, that you have infinitely many solutions, I'll kind of point that out when we see it in my math lab. And then you also need to be aware of when a system is inconsistent, meaning there's no solution. So again, as you're going through the row echelon form and you're reducing it and trying to get ones down the diagonal, notice the bottom row is zeros, but you have a number on the other side, which is different. So it's like saying 0 plus 0 plus 0 is -27. This is not consistent. This is not true. That's what they're showing you here, as opposed to the previous problem when we had a row of zeros and the answer was 0. That is a true statement. So this is true, means that you could have an infinite number of solutions if you have the correct number of variables, or you could get this case where the bottom row is zeros and then it equals a number that's inconsistent, means no solution in that case. I think that will encompass everything that I can just kind of talk about. Now we're going to go over to my math lab and actually do it. Okay, I'm going to show you by hand and with the calculator. So I'll see you over there.